Yes, sir.
So today we will learn how to construct phase trajectory. One way to construct phase trajectory is by solving the differential equation. So we are considering second order system. As we have seen yesterday, we have two equations. X1 dot is equal to F1 of X1, X2. X2 dot is equal to F2 of X1, X2. So if you solve these equations, if you're doing it using computer, you can solve X1 dot is equal to F1 of X1, X2, you can solve and you will get an expression for X1t. You can solve for X2 dot and you will get an expression for X2t. You can make a table. Fida will write here a table. There are three columns. First column is T. Second column is X1t. And third column is X2t. There are three columns, XT, X1t, X2t. So for each value of t, if I know an expression for X1t, I can compute X1t. If I know expression for X2t, I can compute X2t. So for each value of t, you'll get 1 points. So you have a phase plane. So Fida will draw a phase plane also here with the x-axis as x1 and y-axis as x2. So the starting point will be x1, 0, x2, 0. Next point will be x1, say at 1 millisecond, x2 at 1 millisecond. Then you will have x1 at 2 millisecond, x2 at 2 millisecond, and you will get a phase trajectory. This is the way in which the computers can do it. But there are analytical methods and graphical methods. I will teach here analytical method. Graphical method, there are excellent videos in the YouTube. Please watch it. Or sometimes they may ask that also. Watch it, and if you have doubt, you ask me. So let us learn how to construct a phase trajectory analytically. This they may ask for the examination. It's slightly difficult, but it's doable. But the fundamental thing which I want you to understand is, that is why I explained again phase trajectory. You should have the concept of what is phase trajectory. So I'm not going to repeat it. Today's class is a very examination point of view, how to construct phase trajectory analytically. Next slide. So look at this equation. X1 dot is equal to F1 of X1, X2. X2 dot is equal to F2, X1, X2. So what is dx2 by dx1? It is dx2 dot dx2 by dt divided by dx1 by dt. dx2 by dt is nothing but our x2 dot, and dx1 by dt is nothing but our x1 dot. So I got dx2 by dx1 is equal to f2 of x1 x2 divided by f1 of x1 x2. So this don't think this as very mathematical. There's some intuition behind this. You know what is phase plane? Phase plane, x-axis x1, y-axis x2. So this is the slope of the phase trajectory. Please note, dx2 by dx1 is the slope of the phase trajectory. So basically all methods boil down to the slopes of phase trajectory. Next slide. This is slope of the phase trajectory. So what is our agenda? We want the above equation defines the slope of the trajectory. To construct phase, what is our agenda here? We want to draw the line showing the relationship between x2 and x1 as t goes on. To construct phase trajectory, you must integrate this equation. I'm sure that you are good in numericals, good in simple maths. So please ask those students who have missed today's class to learn this. You'll be able to learn this in a very cookbook fashion. So what you have to do is, you got an equation for dx2 by dx1. Now you have to integrate. So integration, I know that 90% of you are good at integration. Next slide. So once you integrate, you will get an equation x2 is equal to g of x1. That is the answer. Once you have x2 is g of x1, you can draw the graph. That is your phase trajectory. Next slide. You must do, so this is the same thing. The above equation defines the slope of the trajectory. To construct the phase trajectory, we must integrate to get the equation of a form x2 is equal to phi of x1 or g of x1. Next slide. So this example, hold on here. This example, we have a spring mass system. So we know from our earlier analysis, the equation, the differential equation representing the system is my double dot plus ky is equal to 0. And for this example, let us assume m is equal to 1 and k is equal to 1. And it is we are considering only autonomous system. Autonomous system means there is no force. So f is equal to 0. So what is the equation for the system? The equation for the system has become very, very simple. It is y double dot plus y equal to 0. Y double dot plus y equal to 0. This is the equation for the system. So to draw phase trajectory, what you require is you have to get equation for x1 dot and then x2 dot. So next slide. So let us define the system in terms of first order differential equation. x1 equal to y, x2 equal to y dot. Therefore, x1 dot equal to x2 and x2 dot equal to y double dot. Fida was starting to write something, so I will thank you for prompting. So the first step in doing problem for the examination is you get an equation. If you can write this, get an equation for x1 dot and an equation for x2 dot. Get an equation for x1 dot and equation for x2 dot. For the examination, they may not ask you the same problem. It could be different, but your agenda should be you get an equation for x1 dot and an equation for x2 dot, x1 dot and x2 dot. So once you get that equation, then things are easy. The next thing is you obtain dx2 by dx1. Next step is obtain dx2 by dx1, which is the slope of the trajectory. What is dx2 by dx1? It is x2 dot by x1 dot, which is equal to x2 dot by x1 dot. So I hope this step is clear to all of you. You have to obtain equation for dx2 by dx1, which is equal to x2 dot by x1 dot, which is in this case, which is equal to, let us go to the next slide. I have written it. I don't want to trouble Fida too much. So what is x2 dot? x2 dot is y double dot, and that is equal to minus y, and that is equal to minus x1. And writing in the standard form, we will get x1 dot is equal to x2, and x2 dot is equal to minus x1. Therefore, what is dx2 by dx1? Minus x1 by minus x2. So I'll repeat. dx2 by dx1 is x2 dot by x1 dot, which is equal to minus x1 by minus x1 by x2. So I'll repeat the two steps. Aditya, what are the two steps?
Finding
Aditya,
finding equations for x1 dot and x2 dot, and
that is the first step. Then after that is the first step, and then second step.
Then dx2 by dx1.
So we are done with two steps. And why are we doing all these things? We want an equation connecting x2 and x1. How will I do that? By integrating this equation. Next slide. So dx2 by dx1 is minus x1 by x2. When you cross, you have to integrate this. When you cross multiply, what do you get? x2 dx2 is equal to minus x1 dx1. To get phase trajectory, what we should do? We should integrate this. I said all of you are good in integration. So x2 dx2, if you integrate it, you'll get x2 square by 2. x1 dx1, if you integrate it, you'll get it as minus x1 square by 2 plus constant of integration. So x1 square by 2 plus x2 square by 2 is equal to c. Or you can write it as x1 square plus x2 square equal to 2c. So let the initial condition be 2, 0. We are starting from the point 2, 0. And by substituting, we can find c by substituting the values for x1, 0 and x2, 0 in 5. We'll get constant of integration 2c as 4. So phase trajectory for the initial condition 2, 0 will be a circle of radius 2 given by the equation x1 square plus x2 square equal to 4. By seeing this, one thing, by seeing this, you know, this is an equation for circle. So the phase trajectory is a circle. We didn't do any experimentation. And the beauty is, once you get this kind of expression, you can draw the phase portrait also. You can draw the phase portrait also. If the initial conditions are 3 and 4, then you will have a bigger circle. So what will be the phase portrait? All wherever you start, you will go in circle. That will be the, so if you start from 3, 4, you will have a circle of radius 5. If you start at 5, 0, you will have a circle of radius 5. So this is the phase trajectory. So let me ask Aditya to repeat this.